All right, we are doing matrices today. Chapter 10 is matrices. Okay, and we do start with 10.3, and I will tell you why with our little intro here. Okay, so on the board I have 2x minus y equals 1, and 3x plus 4y equals -4. Okay, so I asked you guys to think about how you would solve those equations. So what are some strategies you guys remember doing in earlier math classes with these? Yes, you can move like the x's to one side. You can solve for y and then plug that back in. Do you guys remember what that's called? Yep, substitution. Okay, what else? Yep, you can graph them and find what? The intersection, because it would be an xy point. And the last way? Yeah, so you can multiply by something and then add them together. So what would you multiply this equation by so that when you added it, it would cancel out? 4. So we're actually going to be doing some of that today. So actually part of the first part of chapter 10 is solving these, which you guys have already done before. But now, if you had something like this, all right, now that we want to solve that by hand. So remember we just talked about elimination, how you eliminate one of the variables so that you can plug it back in and find the other. For this one, you would have to take these two equations, eliminate like the z, and then you'd have to take these two equations and eliminate the z to create a new system of equations. Then you could eliminate one of those variables, plug that back in, then you'd have to find the other one. So you'd have to do a series of eliminations. That doesn't sound like a lot of fun, right? Okay, well, that is what they do in 10.2. In 10.3, they introduce you to matrices and how we can use matrices to solve systems of equations that look like this and are even larger than that. Okay, so that's why matrices are pretty useful. So today we're going to learn about how to put these systems of equations into matrices, and we're just going to do some notations with matrices. Okay, so in 10.3, this is called matrices and systems of linear equations. And we're going to be solving something that's called an augmented matrix, which I know you don't know what it is right now. Okay, so we're going to solve an augmented matrix. Yeah, let me show you how. Okay, so we're going to solve an augmented matrix using these elementary row operations. Okay, and some of them we already talked about today. It's using that process of elimination where you multiply by a number and then you add it to the other equation. We're going to be working with those. Okay, so what are they and what are they used for? It really is just a way to arrange numbers. Okay, so it looks like a rectangle or sometimes a square, and we're organizing information into categories, and those are going to correspond to the rows and columns of the matrix. An augmented matrix is formed when we represent that linear system with a matrix, and then we can apply what we know about solving systems of equations, okay, to the matrix here. Okay, so an augmented matrix, if you look at this linear system, you just take these coefficients. Okay, so the coefficients of x are in the first column, 2 and 1. Coefficients of y, -1 and 4. And then the last column is going to be the constant term, 5 and 7. Generally, we write them in rows. We'll do 2, -1, 5, 1, 4, 7. Okay, so that's how we're going to be using what is called the augmented matrix. The definition of a matrix is you have this M by N matrix. Okay, M is the rows, N is the columns, and that is your dimension. So your dimension is an M by N. As always, the rows by the columns. Okay, so these are the entry numbers. I had, bless you, I had some of these up when you guys walked in. So it looks like A11, A12, A13, but it really means A11, first row, first column. 1, 2, first row, second column. 1, 3, first row, third column. Okay, so they are the two numbers together. Okay, so if they ask you for the dimension of a matrix, it's just the rows by the columns. Okay, so a 2 by 3, a 1 by 6, okay, whatever you have. And then the terms, okay, they are called A, and then it's I and J. So I is the row, J is the column. The ith row, the jth column, which feels weird to say. I'm going to practice it. The jth. You guys ever said the word jth before today? The jth and the I. Okay, so what we're going to do now on the next page is you are going to say what the dimensions are of those two matrices. Okay, so just write it right next to it. Okay, so the rows by the columns. The rows by the columns. Okay, so Ilaria, for the first one, how many rows do we have? Okay, so the dimensions are just going to be the rows by the columns, okay? So in this matrix, how many rows do we have? Is what I'm asking. Yeah. Okay, so this is going to be a 2 by, and then Anya, how many columns do we have? 3. So it's the rows by the columns. So this is a 2 by 3 matrix. Okay. And then Kinley, what's our second matrix going to be? 1. Yep. So you have 1 row, and how many columns? Yep. So it's a 1 by 4. Okay, so you're just doing the dimension. Is that okay now? Okay, so the 2 rows, the 3 columns. 1 row, 4 columns. Okay, now we're going to write the augmented matrix. So we can write the system of linear equations as a matrix, and that is called the augmented matrix. Okay, and all we have to do to write that is take those coefficients and the constants that appear in the equations. Okay, so your augmented matrix here. Okay, I'm going to do the first row. We have 3, -2, 1, 5. Okay, so I want you to do the next 2 rows. Okay, and then Cedric, what will our next row be? Good. Okay, and then Marjorie, what'd you get for the last row?
-1, 0, 4, 1.
Great. Okay, so this is asking you if there's no variable, what do you put in the augmented matrix? So what did we do when there was no y here? Yeah, you just put in 0 as your placeholder. Okay, so if there's no variable, you're going to put in 0 as your placeholder. Okay, now when we are solving these augmented matrices, okay, we want to solve the system, okay, so that we can find the x, the y, and the z. In order to do that, we're going to use what are called elementary row operations. Okay, so we use these elementary row operations. Because if you use one of these, okay, it does not change its solution. That's why we're allowed to do it. Okay, so we can use these elementary row operations because they do not change the solution. So one thing we can do is add a multiple of one row to another. This is what we talked about when we talked about how we're solving those equations. So when you're multiplying, it just has to be by something that's not 0. Because if you multiply by 0, that does change the value. Okay, so you have to multiply by a non-zero constant. And then you can add that to another row. So when it says add a multiple of one row to another, you're just multiplying by a value that's not 0, and then you can add that to another row. Okay, and then the second thing is just you can just multiply a row by a non-zero constant. You don't have to add it to anything. If you do that, again, it just can't be 0. So you can multiply. Oh, can you guys see that? Okay. Yeah, multiply it by any number besides 0. It's like a nice orange sherbet color. I like it. Okay, and then the last thing is interchange two rows. Okay, so if you're interchanging the rows, you are just switching the positions. So you're switching their placement. Okay, so you could switch rows 1 and 2. You'd have to rewrite row 1 in the second row and vice versa. Okay, so you can just flip those 2 rows. And then there's special notations that we use to describe these elementary row operations. So there's certain ways we have to show what we're doing. So we're going to practice those here. So one thing you can do is multiply the first row by 3. So you have a matrix, and then you apply the operation, and then you have this new matrix. Okay, so we're going to call this the original or the OG matrix. We'll call this one the new matrix. So you have to show what you're doing to get from the original to the new. So if you're multiplying row 1 by 3, on this arrow, you just write 3R1. Okay, so that means you're multiplying row 1 by 3. All right, and then if you want to switch 2 rows, so you're always doing one matrix to another. And if you want to switch the 2 rows, okay, you do a double arrow. So you're going to switch row 1 and row 2. Okay, now this one is going to be a little bit longer. Now, with this one, you were just multiplying one row. Here you were switching. But when you add 2 rows together, you can put the result in either one of those rows. So this says we're going to add row 1 and row 2. We're going to put the result in row 2. Okay, you could put it in row 1. That's why we have to say where it's going. So we're going to add row 1 and row 2, and then the result goes in row 2. That's how we would notate it. So anytime you add 2 rows together, you have the option of where to put them. So if you add row 1 and row 2, and you want your result in row 2, this is your notation. Okay, do you guys want to try to write the third notation on your own? You're going to multiply row 2 by 2, then add it to row 3, and then put the result in row 2. So multiply row 2 by 2, add it to row 3, put the result in row 2. Okay, so we're going to do 2 times row 2. We're going to add that to row 3, and then we put this result in row 2. Okay, and now we are ready to use these operations. Okay, so we're only going to do one example together, and then I'm going to give you time to practice, because really we just need to become familiar with the notation and the process here. So we're going to solve a system of equations using the augmented matrix and the elementary row operations, but let's make sure we understand what our goal is. Okay, so when you are solving these, you're trying to find your x, y, and z. And when that happens, like I told you before, it's like you have to take these equations and eliminate a variable. You want to take another equation and eliminate another variable so you can find them. So our goal is to eliminate the x term from the second equation. So you want to eliminate the x term from the second equation, and from the third equation, you want to eliminate the x and y terms. So I'm going to show you what that looks like on my paper here, just so you can get a better understanding of what's happening. So if you were to eliminate, and this wouldn't be accurate, just so you know, I'm just using this as a visual. Okay, it says to eliminate the x term from the second equation. So I'm going to keep the first equation the same. Okay, if I eliminate the x term from the second equation, then I just get something that looks like this. And then if I eliminate it says the x and the y from the third equation, then I get something that looks like this. And eventually, I'm going to change this to a 1. Okay, eventually what you want is you want 1z to equal this last value, because if you know that z is equal to 9, then you can plug that into this equation and solve for what? Y. And then you'd have z and y, and you'd be able to plug those back in here. So this is called back substitution. So what this does is it creates a system where we can use back substitution to solve. And it's back substitution because you start with the z, and then you work your way up from there. So if we reach our goal, we're going to write what this matrix is going to look like. Okay, so what we want is we want to have 1 in the upper left-hand corner, and then we want zeros below that because we want to eliminate the x's in the second and the third equation. Okay, we also want the coefficient of y to be 1 in the second equation, and we want this to be a 0 underneath it. And then we want the z, the coefficient of z to be 1. Okay, and you can see I'm missing some entries there. Those are just going to be numbers. I'm going to give them variable names. So if you have this matrix, it's a 3 by 4 matrix. So this would be an A, this would be a B, this would be a C, this would be a D, this would be an E, this would be an F. Can I put this here? Okay, and you want this set up so that you have X plus AY plus BZ is equal to some value of C. Then you want Y plus DZ to be equal to E. And then you want 1Z to be equal to F. Okay, so in this example, this is where A through F are constants. Okay, and this type of system is also called a triangular system. Okay, and that's because you want these here to make that triangle. So if you have this triangle here, you can use that back substitution. Okay, so technically your first step is always going to be to put the system in an augmented matrix. Okay, so I said aside from doing that, because you want it in an augmented matrix first, okay, after it's in the matrix, what should our first step always be? And it's always going to be to get this value of 1 in the upper left-hand corner. Okay, so we're going to start by obtaining a 1 in the upper left corner. Okay, so in the matrix, okay, this is what you're going to do first. And this should always be a 1. Okay, your second step is going to be to get zeros underneath the 1 in the first column. Okay, get zeros underneath the 1 in the first column. Okay, so that means you want to get a 0 here and you want to get a 0 here. Okay, step 3. Now you want to get a 1 in the second row, second column. You want to get a 1 in the second row and the second column. And then after you get a 1 there, you want to get a 0 below that. Okay, so after you get a 1 in the second row, second column, you're going to get a 0 below that 1. Okay, and then if you had more than a 3 by 4, you would keep repeating that process Okay, we're not going to have anything larger than that today. Okay, so your last step, just going to put repeat, getting a 1 for third row, third column. Okay, so that would be here. There's no more zeros, but there's no more rows below that, but if there was, you would get zeros below that one. Then it would keep going. Okay, so we get a 1, we get the 2 zeros. We get a 1, we get the 0 below, we get a 1 here. Once we've done that, we have the triangular system and we can use back substitution. Okay, so our system of equations is given. Okay, we are going to write the augmented matrix. Actually, will you guys write that augmented matrix for me there? So you have your augmented matrix here. Okay, so we're just going to put those in the columns. All right, and then once you've written down your augmented matrix, I just want you to look at what your first step is. Okay, so your first step is to obtain a 1 in that first row, first column. With this one, you already have that. Okay, if you run into a situation where you don't have that, so let's play pretend for a second. Let's pretend this isn't a 1, okay? Do you see how this row has a 1 in it? If this doesn't have a 1 here, but the next row does, your first step should be to flip the 2 rows, okay, to switch them. But for this one, we have a 1 there, so we're good. So step 1, already done, okay? Because we're only doing one example together, I am going to write the directions down so you can use this for all of yours. So get a 1 in A11. So remember, A11 we learned earlier today means first row, first column. Okay, and then in this case, it's already done. Okay, so we can just write our matrix here. Okay, and really the key to these is keeping a neat matrix, because sometimes we cram too many things together, and then when we have to do the elementary row operations, it's hard for us to read it clearly. Okay, so that's just a little piece of advice for you to help. All right, and now we are going to get zeros underneath the 1 in the first column. Okay, so if we're going to do that, I recommend that you always do the opposite of this leading 1 is what we call this. Okay, this leading 1 here. And so if you multiply by the opposite, if this is a 1, you want this to be what number? So that when you add it together, you get 0. What number do we want this to be? So when we add them together, we get 0. -1. Okay, so we can multiply row 1 by a negative. We can add that to row 2, and we can put the result in row 2. All right, so let's do that part together, okay? So if I do -1 plus 1, I'm going to get 0. Yay, that's what we wanted. Okay, for the next one, -1 times a negative is +1. 1 plus 2 is, everybody? Everybody. 3. All right, I'll have you try the next two. Okay, so find the next two values there. And then once you've done that, the other rows, nothing changed. So we can just put those there. Okay, so Anya, what'd you get for the next one? That, oh, I just want this one.
Oh.
Yes. Okay, so -3 plus -2, -5. All right, and then Ilaria, what'd you get for this one?
6.
Yep, so -4 plus 10, 6. Okay, do you guys have any questions for me? All right, then let's get this 0. Do you guys think you can, why don't I let you think about it for a second? Do you guys want to think about what your row operation is going to be? So you're trying to get a 0 where? Yeah, row 3. Okay, in column 1, row 3. Okay, so here we did the opposite of row 1 and we added it to row 2. Now we're just going to do the opposite of row 1 and add that to row 3. So what's the opposite of row 3? What's the opposite of 3? -3. So we're going to do -3 times row 1. We're going to add that to row 3. We're going to put the result in row 3. Okay, and if you guys want, if you know like you're just changing row 3, if you want to write those first, you can, or you can write them second. It just, whichever you prefer. Okay, so then -3 times 1 is -3 plus 3, 0. -3 times -1 is 3. 3 minus 1, 2. -3 times 3, -9. -9 plus 5 is -4. Okay, and then do the last one. Okay, so -4, or -3 times 4 is -12. -12 plus 14 is 2. All right, now that we have the 1, 0, 0, we need to get a 1 in the second row, second column. So when you're doing that, so we got to get a 1 in A22. Okay, second row, second column. Okay, so the simplest way to do that when you already have this 1, 0, 0 here is to multiply by the reciprocal. So if you take row 3 or row 2 and you multiply by the reciprocal of 3, if you do 1/3 times 3, you're going to get 1. Okay, yes, sometimes that produces fractions, but sometimes the fractions are unavoidable. Sometimes they are. It just depends on your situation. Okay, so if I do 1/3 times row 2, the reason why this is nice is it doesn't change this 0. I'm still going to have a 0. I'm going to have a 1. Negative 5/3. 6 divided by 3 is 2. Okay, and then my other rows are going to stay the same. So I have 1, negative 1, 3, and 4. 0, 2, negative 4, and 2. And then we want to get a 0 below the next column. Thank you. Okay, so we want to get a 0 below A22. Okay, so once you've gotten this 1, you want to use it to help you get this to be a 0. So we're going to multiply by the opposite so that this is a 0. So if this is 2, I want this to be negative 2. So we're going to do negative 2 times row 2. Okay, and then we're going to add that to row 3. And that's going to be our new row 3. Okay, so I want you to go ahead and do that for your 3rd row. Okay, and because we're only doing row 3, I'm just going to write in my 1, negative 1, 3, 4, 0, 1, negative 5, 3, and 2. Okay, so the reason why this is great is because now I'm multiplying by 0. 0 plus 0 is going to keep that a 0. So by using this 1, I'm not messing up anything I've already done. And then negative 2 plus 2 is going to be 0. Okay, when I do the fractions, I like to write them out. That just helps me. So negative 5/3 times negative 2 is 10/3. Okay, and then it's plus negative 4 or minus 4. So I like to get my common denominator. And then from there, I can say, okay, 10 minus 12 is negative 2. And then 3 is the denominator. And then negative 2 times 2 is negative 4. Negative 4 plus 2 is negative 2. So it is a lot of mental math. Feel free to write things out if that is easier for you. Okay, and now we just have one more step. Our last step is to get a 1 in A33. Okay, 3rd row, 3rd column. Okay, so anytime you are getting a 1, the quickest thing to do is multiply by the reciprocal. So what's the reciprocal of negative 2/3? What's the reciprocal? Negative what? 3/2. Okay, so then we're just going to multiply everything in row 3 by that. So if I multiply by 0, I'm going to get 0. Okay, a negative times a negative is positive 1. Negative times a negative would be 6/2. Okay, and then my other rows are going to stay the same. So 1, negative 1, 3, 4, 0, 1, negative 5/3, 2. So now I have that triangular system. Okay, remember this is called the triangular system here. So now we are able to do that back substitution. Okay, so now we are ready to solve. And the system that we have, we are going to write out. Okay, so our system is 1x minus y plus 3z equals 4. Y minus 5/3 z equals 2. Okay, and then z equals 3. So in that system, the first thing is always going to be that value of z. And then we are going to plug that in. Y minus 5/3 z equals 2. Solve for y. X minus y plus 3z equals 4. Okay, so go ahead, plug those in and solve. Okay, so if z is 3, those will cancel. You have y minus 5 equals 2. Add 5. You should get y is 7. Okay, and then we're going to plug in both 7 for y and 3 for z. So negative 7 plus 9 equals 4. X plus 2 equals 4. Subtract 2 from both sides. X equals 2. Now we have the x, the y, and the z. So when we write our solution, we're going to write it as a point. Okay, so your point is in the form x, y, z. So in this case, you have 2, 7, 3. Okay, and that's going to be your final answer. All right, and then your homework for 10.3, day 1 is on 659, 19 through 22.